Welcome, chemistry class. I know you've been anxiously awaiting this day when I could get some videos to you. You've probably watched all of the physics videos, even though you're not in that class, 3 or 4 times. So I know you've been waiting for this on pins and needles, right? So the pressure really has been on me to put this out. In fact, so much pressure, we are going to solve a gas law problem today. Problem number 12, which was requested by one of your fellow classmates. I'm excited to get to work on it, so let's just jump right in. Okay, so in this problem, we're given this information here. We want the mass, we know volume, we know temperature, and we know pressure. So immediately you think, well, what can we use? Okay, well, you know you have PV equals nRT. That's the ideal gas law here. So you're given a volume, you're given a pressure, you're given a temperature. Now it gives you N. Well, what is N besides the letter of the alphabet? Well, for us, it is moles, number of moles. Well, if we want mass, how are mass and moles related? Molar mass. That's right, the molar mass. And are we given the compound? That we are. Sulfur dioxide. So we can easily find the molar. So if we get the moles, then we can go right to the mass and we have our answer. We do have a few road bumps on the way there. Okay? So when we use this, R, what is R? If you recall, R is the ideal gas constant. I always use this. 0.8206 liters times atmospheres over moles times Kelvin. Well, what does that mean? That means those are the units that you must get on these other things here. So liters, atmospheres, terrible handwriting, moles, Owen times Kelvin. You've got to get those units on here. So let's take stock here and see what we've got. We got a volume in milliliters, and we got to turn to liters. Temperature in Celsius, always turn to Kelvin for these. And kPa, that's not atmospheres. We could choose a different R value, but that made these lives easier, but I think it's just better in general to always use this one and convert everything to those units. All right, so what do we have? Our volume conversion. Okay, 1,000 milliliters in a liter. Here we go. We multiply by 1, divide by 1,000, 0.2287. Move it over 3. Temperature conversion. Okay, Kelvin to Celsius to Kelvin. We fill into our formula here. Simple formula. Okay, we had a student on a previous one give us this formula too. I was very happy about that. That you guys are helping each other out, and that was a good temperature conversion stuff to put on there. So here we go. We end up with 259.55 Kelvin. Pressure conversion, we have here kPAs. So what is our conversion? It's in the notes Mr. Bishop had given to you, and what I gave to you, 1 atmosphere over 101.325 kPa. You cancel the kPa out, and you're left with atmospheres. So we have this, we have this, and we have this, all in the right units. And we're going to fill into this formula right here. And I have done so right here. Okay? Pressure. Oh, look, that cancels. Volume. Oh, look, that cancels. Kelvin. That cancels. And we're going to be left with moles on our answer. You just multiply those two, multiply these two, divide this quantity by that quantity, your order of operations, and we end up with this. This is not our complete answer. We have one more step. Remember, we had to get the molar mass. How did we get the molar mass? We added up using the numbers on the periodic table. 16 for oxygen approximately, and 32 for sulfur. So when you add those up, 2 16s and a 32, you get this. Moles cancel, we're left with grams, 50.5159 grams of sulfur dioxide. Please keep the questions coming and keep the likes on my videos. I am now in a competition with Mr. Jeffers, so please watch it often, like it often, and I'll see you around.